gosh, guys, I'm so excited to see you. Okay, today's topic is going to be about the states of matter, and I'm gonna start calling you guys by a new name that I will introduce at the beginning of the video. And yes, again, I have taken a lot of time on this video, so yes, I really hope you enjoy it. Hello, academics. Today we are going to learn about the states of matter. So here we're going to just put liquid platinum into this container, and then we will see how it reacts when we freeze it. Oh, and this is just a friendly reminder, metal does have a boiling point. Now, as we advance into the animation, notice as the molecules get more and more tightly packed. This is called solidification. And would you look at that? A glistening metal shard. Now, we should heat it. Alright, now that it's heated, we're back to where we started, the liquid state. But what if we apply more heat, more energy? It chaotically spreads throughout the container, then condenses and turns back to liquid. Now let's review. Liquids, of course, take the shape of the container. Oh, also, the molecules are fairly stable, but they can still flow, unlike solids. It's a type of fluid along with gas. And liquid cannot be compressed, so let's add that to our list. And here's a cool fact. We wouldn't be here without liquid. What about light and electricity? What about fire? Okay, fire is a type of plasma. And I'll answer since you asked. Unlike gases, the electrons tend to free from atoms, and there is an imbalance between the photons and electrons. It's pretty much just ionized gas. I'll go over that later. It's confused with plasma and blood. That's a topic for another day. It's extremely hot, and of course there's an imbalance of electrons and protons, which means an imbalance of ions, which are pretty much just atoms with an imbalance of electrons and protons. Let's go over examples of plasma. The sun's coronal mass ejections and solar flares. It's created by lightning. And of course, burning hot fire. Now let's go over the differences between plasma and gas. They're pretty similar, but if we go into the atoms, some of the only things that are actually smaller, we will see. Here, we will see the protons, electrons, and neutrons orbit the nucleus, but the protons and electrons can get straight up messed up when exposed to thermal energy. I think it's time we go over examples of gas, like thick misty clouds, for example. I could go over how this works in the entire hydrologic cycle, but that's a topic for another day. Jupiter's thick atmosphere could also be another example of gas. And now for the solids. Alright, let's review. Solids have a consistent shape, a consistent volume, they have low kinetic energy, and stable molecules and atoms. The molecules are densely packed together. Solids are generally the densest state of matter, of course. And fun fact, we are solid and liquid. More liquid, actually. On to gas. Alright, gas and plasma are the most common states of matter. Gas spreads to the borders of its container. Gas and plasma are the least dense states of matter. They can be found anywhere on the planet. Unlike liquid, gas, solid, and plasma can be compressed. Gas and plasma have a lot of similarities. We cannot live without gas and plasma. Now, I know half of you, at least half of you, have wondered this in your life. What is light? Simple. It's energy. It's electromagnetic radiation that aids us by going into our retinas to detect it and send it to our brain to the optic nerve so we can see. The subscribe button and smash it to bits. This is a diagram of a real water molecule. They make up the entirety of the water on our planet. We simply cannot live without them. All states of matter have some home on the planet. Guys, I have simple instructions for you to follow, alright? All you need to do are these three things. Follow these instructions and you'll be good to go. With these three buttons pressed, you'll be notified when I upload.